I'm Deanne Hughes, and thank you for coming to a talk after lunch on regulations and standards. I am fairly sure that this is not the most exciting presentation being done during this slot, so thank you for coming and joining me on this conversation. We've done this talk for many years, and I keep thinking, well, there's not going to be anything else to say on regulations and standards, and then things change. And we have had some really great presentations this week on change. So we're going to focus on that today. Let me tell you a little bit what I have as a lineup for you. Oh, and the little clicker will work for me. So we're going to do a couple things today. We're going to talk about some standards, what's new and what has changed. We're going to talk about some research and development on the standard side as well, some things that our friends at ASTM are working on primarily. Then we'll talk about regulations, primarily focused in North America, because that's where many of you are from. We had a really great international day earlier this week where we had a little bit longer conversation on international implications. After we talk about regulations, we're going to talk about what's on the horizon there. Lots of change, as we've heard earlier this week and from Mark yesterday. But I hate to leave you with all of only talking about change, so we'll talk about some of the things, and especially for those of you who are new. How many people are first time at Infusion in the room? Great. So if you take nothing from this presentation today, I hope that you walk out knowing that you do not have to start with a blank piece of paper when customers ask you questions. There are a lot of resources within our industry and a lot of resources at McElroy that are tools in your toolkit. So we'll talk about those today. And that we're your pit crew, because we are driving expectations this week. So let me tie in the theme a little bit. Okay, so let's talk about standards, primarily at ASTM. They drive quite a bit of work. And this slide is going to give you some of the standards that have changed this year within F17. It is the Plastics Pipe Subcommittee of ASTM. ASTM is an ANSI accredited group, which means that standards can be incorporated by reference into regulations within the United States. So it's an important group. It is consensus-based, which means that when standards have changes being made to them, those people who are voting members of F17 all have to agree. Not majority, not 2/3. All of them have to agree that the change should be made before change happens. So standards are really important because they come from industry and they help inform things that happen on the regulatory environment. So you see here some changes on construction type standards with directional drilling, standards around materials, both for polypropylene and for PERT down the middle. Tracking and traceability, who's heard those terms? Who's heard that term in the last six days maybe, right? It's a really important question. It's been around for a while, but I would say that until recently, there really hasn't been the technology to do this aspirational goal of tracking and traceability that we are now seeing really be able to come to fruition. And then last week, the update to the data logging standards was finalized at F17. Okay, so those are some new ones. In your app, there is a link on this session's page that have a whole bunch of helpful regulatory and standards citations that might be helpful to you in your work. So there's like 11 pages of them. It's updated as of the end of September. So if you would like that document as a PDF with the hyperlinks working, just send me a note either through the app or my contact information is at the end, and I will get you the document so you can actually hyperlink, okay? You do not need to write all these down, I guess is the shorthand answer of the slides. F17 also has some work in process that might be of interest to you, and I'll throw these up here for you as well. Oh, sorry, too far. There we go. There's a work group working on a standard around heavy wall fusion. Polypropylene fusion is almost done. It is super duper close to being ready to ballot. A PA66, which is a nylon based material. Specification is in work groups as well. And then we're working on a dissimilar wall thickness. If you remember in F2620, we have a clause that says 1 SDR difference, same outside diameter is fine to fuse. And we're trying to put a little bit more description around that standard, and it's been balloted. Sergio.
F17, it's good to say that it's the ASTM group that take care of the, right?
Right, so ASTM as an organization has groups for steel and concrete and plastic pipe and desks and chairs and carpet and walls and everything. F17 is the group that deals with plastic pipe. And those standards are organized around that topic. But I'm appreciating your question because my next slide is going to talk a little bit differently, so I'm glad you asked the question.
Yeah.
And then we have squeeze off for natural gas distribution. It's been a good question that we've been wrestling with for a while, and there's a work group working on that one as well.
So heavy wall, heavy wall, I mean, Jim Johnston presented as a good practice a couple of years ago. And now you have an ASTM document that is going to talk about, I mean,
so
maybe tomorrow is going to become to be a standard? Like,
so, Sergio, I don't know have the answer to that question. The work group is being led by Harvey Speltnick, and I think that there's a lot of opportunity around helping people understand how heavy wall fusion looks differently than a thinner walled fusion. I would say that work group is probably at the beginning stages of its work rather than it closer to its end. Okay, so Sergio asked about what does F17 mean. And while we're here today, I wanted to make sure for those of you who follow ASTM standards, it is worth paying attention to the E60 group. This is a sustainability and environmentally focused group that historically would have been focused on kind of big picture thinking. How do we talk about buildings? How do we talk about climate? How do we talk about resiliency? But they are becoming a little bit more specific, and they have some sustainable agricultural practices that could certainly impact our customers and our materials and our products around water use in agriculture. And they are also looking at how climate change and extreme weather affects infrastructure, both buried, in this case, a buried drainage structure, but also how floods and wildfires affect culvert design. So they are walking kind of into a more specific place than they have historically worked that could certainly impact our material choices on potential job sites. So it's a committee worth watching. And if you are so inclined, it's a great one to join. And they're also talking about circularity, which is the idea of how do we return resources back into the market system, whether it is back reusing your water bottle or whether it's turning those back into molecules to go back into the front side of the plant. So circularity and then resilience as well. So that's E60. Any questions on F17 or E60 or standards, North America?
Is E60 more corrugated pipe than it is solid wall pipe though?
In E60? Yeah, I'll repeat the question. So his question was whether E60 was dealing more with corrugated pipe. And right now the answer is yes, only because they're talking about culvert design, which tends to be more corrugated material, but that doesn't preclude them right now from wanting to be somewhere else. So thank you. Okay, so for our international friends, ISO is also a busy organization, and plastic piping systems are regulated there under TC 138. I'm going to put up here just those ISO standards which have had changes in the last year and a little bit. ISO organizes their rules a little bit differently than in the United States. These are organized around water. When you're up looking at SC2, industrial applications, and SC3, gas for 4, and then kind of the networking system-wide for SC8. So those are the things that have happened at TC 138. Jim Johnston is on this committee. He tells me that there's not a lot going on, that the fusion standard probably will be put back into like a working draft kind of review in the next year or so, only because it's up for another relook. So if you have questions on ISO, please let Jim or me know. Okay, back, ASME, how many of you have read a specification that addresses or that says that they're going to use B31.8? Do you see it? You do?
31.3.
Okay, so some differences. That's kind of interesting. 31.8 had some changes, which is on the gas side for ASME, and they did some changes with bends and elbows in 2022. Not a big change there. Our Canadian friends had some changes for 137, which is sort of the equivalent for our F2620, sort of. And looked at, they had some changes in humidity tolerances, but not something that I would be too concerned. I don't think we need to go into those. And then NSF, this organization is not the National Science Foundation, which is what I thought it was when I first started this. NSF has these two standards, 14 and 61, and they deal with health effects and performance standards of pipes as it relates to moving potable water. And they have updated some of their standards related to testing for infiltration of toluene, ethylbenzene, and xylene. So those are the changes. Again, the pipes that you are making or the pipes that you are using have to carry an NSF certification if they are being used in potable water. Any questions on those? Sure, Sergio.
Most, 99% of the mining design specification in South America are based in ASME. For some reason, they use the B31, which is divided in metallic and non-metallic.
Right.
And non-metallic, they mention the thermoplastic, where the majority of people use that to fuse pipe.
Right.
But in that chapter, that is referred as a bonding procedure specification.
Right.
Not fusion.
Right.
So and it's hard. And they ask you to qualify with qualify the fusion procedure specification, which is referred to the 2657, which is polyolefinic.
Right.
And I think it's a lack of knowledge or some misconnection that ASME should refer the polyethylene to the section 9 and try to, or include the section 9 to separate which is polyethylene from the other thermoplastic. So
right.
It's a really,
Yeah, I think Sergio's pointing out that within where he's working in some mining applications in South America, that they're pulling some ASME standards that are more convoluted and that talk about bonding rather than fusion.
Right.
And so my suggestion would be, there are some ASME places where you can tie back to ASTM F2620, which would be helpful to you. And I think we can also, at the end, we have some really nice resources for engineering specifications that we could take to those places that have these different approaches and say, here's an option that we might look at that would actually probably save your job. A, you would be able to hire people who could really do it, and B, would also be very helpful to your job. So hold that thought, and Jim and I are certainly happy to help you work through those as you find them. So thanks for bringing that up. Other questions on standards? Okay, well, let's talk about regulations. You know, this is sort of where I cut my teeth for 30 years, was in helping customers comply with regulations, not necessarily with PHMSA, but with EPA. So we're going to talk about PHMSA first, because PHMSA regulates what? Natural gas and hazardous liquids, and they would like to also regulate your CO2, by the way. Everybody wants to play in the CO2 world right now. So we talked quite a bit a year ago about PHMSA's rulemaking. And we're not going to talk as much about that today as we did last year. But I am going to point out to you that equipment inspection requirement in 49 CFR 192 is being inspected by state regulators now. We are hearing that we have regulators showing up on job sites. They're looking for their information for equipment inspections. And there is only one sentence in 192, and this is what it says. Each operator must maintain equipment used in joining plastic pipe in accordance with the manufacturer's recommended practices or with written procedures that have been proven by test and experience to produce acceptable joints. So, for those of you who have equipment in the field on natural gas jobs, it's going to be really important that when you send it to the field, you have the records that say it's been inspected in accordance with manufacturer's recommendations or with whatever the requirements are by that particular job owner. Okay? We can talk about at the end how you can accomplish that, but really important, they are getting inspections on that. The two other ones I put up there, NPRM, Notice of Proposed Rulemaking. These are rules that have been in process for years. There's the original advance notice are literally years old. They were finally published in June and in August. They are hundreds of pages long, and they gave the public 60 days to read it and to submit comments. Comments are now back in PHMSA's hand, or the August ones are due next week. Those will go back into PHMSA for them to review. There are tens of thousands of pages of comments already on both of those rules. It will take some time to go through those, but ultimately we are going to see some additional regulation there. I think from a standpoint of McElroy equipment or the work that we're doing, goodness gracious, sorry. There we go. The piece I would like to leave you with here is that the LDAR, Notice of Public Rulemaking, talks a lot about traceable, verifiable, and complete records. That's location, that's material, that's who did it, that's who owns it, that's what testing happened with it, traceable, verifiable, and complete. That's a big component of that LDAR rule. It's echoed a little bit in the gas distribution with the lens of preventing overpressurization accidents. The second rule is really driven by the Merrimack Valley explosion. Okay, so that's PHMSA. Currently, rules in process. EPA, a little bit less rule-making driven, but we still have two things to think about here. The infrastructure and climate, EPA is very interested in environmental justice and in carbon, and they're driving some work in those two spaces, and of course the lead service line replacement continues. Any questions on those two? And then finally, I have a little European flavor for the day for you, the European Green Deal. And this is about $600 billion worth of funding in the EU to address energy, environment, climate, water, all things that really polyethylene pipe can really help support and improve. So I think there's a huge opportunity in Europe for plastic piping systems to be a part of the solution and to be perceived in that way. Any questions on those? Okay. What do I see on the horizon? PHMSA has some rulemaking that they tell us will be done. The first one up there, class location, is an end of the year. This is really geared at piping systems and natural gas, either distribution, primarily distribution, that originally were kind of in the rural areas, and now the cities have grown up, and so they're no longer rural lines. They are now in more populated lines, which changes their class location, which changes some rules around them. So those are the rules we expect by the end of the year. They are proposing some rules on CO2 pipelines first quarter next year. Some people are thinking about maybe natural gas piping systems become CO2 piping systems, and if they do, what does that mean? PHMSA really wants to be the one that regulates that. So they are going to propose some rules kind of first at bite of the apple. And then some operational status, which should not affect us. There is a CO2 transport system build out. There is money out there for basically building out a CO2 transportation system. Those grants are due next week. And if anybody is interested in working in CO2, that's certainly on the horizon. Okay, other things that are on the horizon. Who has heard about hydrogen? Oh, it is the solution to everything, isn't it? It's amazing. Hydrogen is the answer to everything. Okay, well, maybe not, but there is a whole lot of money being thrown at hydrogen right now, and one of those is through the hydrogen hubs. Who knows where they live and how close the nearest hydrogen hub is? Has anybody heard of hydrogen hubs? No? I get to tell you something new today? This is so cool. Okay, so hydrogen hubs is a DOE idea that says we can make hydrogen, but if no one wants to buy it, then why are we making it? And if I say I'm willing to buy it, but there's nowhere for me to buy it, then I can't do anything with that desire. So the thought is we're going to throw billions of dollars into 7 different places in the United States where we are going to basically build both the demand and the supply side for hydrogen. So we're going to find users who want it and people who want to make it, and we're going to put them together. We're going to give them a whole lot of money. We're going to call them hydrogen hubs. If I'd known that you didn't know, I would have put a map up. That's so cool. We are very close. They should have actually already announced it. The Department of Energy was supposed to announce the 7 winners the first week of October, and she delayed it until, I think, the end of the month. There's one in Texas. There's one that is Arkansas, Louisiana, and Oklahoma. There's one in California. They will ultimately fund 7 of these places. So watch for hydrogen hubs. It's got to move somehow from whoever makes it to whoever's going to consume it. Freshwater, Dustin has talked about it. Mark talked about it yesterday. Freshwater is a big deal. Whether it's drought, whether it's flood, whether it is saltwater infiltration up the Mississippi River, freshwater is a big deal. And I think we'll see continuing interest in how we manage our water resources. Circular economy, probably a little farther out. And the second one, climate and carbon. I put the PFAS and microplastics on here primarily to remind me to share with you that if you are getting those questions, how many of you have had questions from your constituents around PFAS or microplastics? Okay, a couple. PPI did 2 statements this year on PFAS and on microplastics within polyethylene systems that I would point you to. They have done some work, and those links are in those documents I gave you. Okay?
Sorry, what's PFAS?
PFAS are the forever chemicals. They are regulated by EPA under Superfund, effectively, and they are chemical bonds that are very hard to break. And the thought is that, oh my goodness, are they coming to us through our plastic pipes? Because, of course, plastic has the letter P, and PFAS starts with letter P, so they must be related. Thankfully, all of the work that we have done so far has said that there is not a PFAS component that is being moved through our plastic pipes because of our plastic pipes. But it is certainly a question, and EPA is going to regulate. In fact, EPA is regulating it as a Superfund chemical today.
Many of them are banned in Europe already.
Most of them are banned in Europe already. Yeah. Okay, and then microplastics. Fun fact, where do most microplastics come from?
Textiles.
Brandon wins, car tires. Yeah, car tires and actually the soles of your shoes.
Over 60%.
Not kidding you. Yep. It is not little bitty pieces of plastic from that you would think of, oh, it like got on the beach and then the beach worked it away. That's your cars and your shoes. Okay. So how many people have been asked about non-destructive testing in the last year? Okay, we had a question during the International Day as well. So I thought it was worth having a little time to talk about those two things because I feel like it comes to you and maybe this could be a helpful piece of information. PPI does have a technical note related to non-destructive testing, TN60, ASTM. There are some standards for non-destructive testing, but not from a standpoint of how you qualify a fusion joint. It is qualifying the apparatus which is doing the inspections. Okay? ISO has spent 2 or 3 or 4 years with different technologies in a round-robin experiment to see if results were reproducible and if one type of testing was better than another at identifying bad joints. And the conclusion has been, keep working at it. There is not reproducibility, and nor was there consistency in the results. So NDT has some potential, but it is not there yet. And if customers or contractors are potentially interested in this, what I might suggest to you is to take them back and remind them that you cannot inspect quality into anything. You can't inspect your way to quality. You have to design quality from the beginning. And for us, and for you, we think about quality as a qualified operator, working with a properly operating machine, with quality products, and a qualified procedure, and keeping records to document that those things are all true. And when you do those things, then you end up with a quality fusion joint that is reproducible, and you have the records to document the people, the place, the product, and the process that were used. So as you have questions around non-destructive testing, to the degree that you can turn the conversation to, I think what I hear you saying is that you're looking for a confirmation of quality. This could be a way to help people think through that question. Okay? All right, I promised you that you are not alone and that there are lots of resources out there to help you. So we're going to go through those here as well. I picked, I think, 3 or 4 organizations here to help us. The first one being the American Water Works Association. They have a couple really great documents, and I have them linked for you. One is the Utility Asset Management Report. This is looking at utilities, and they have done this survey every 5 years for some period of time, and looking at how they are changing the way they approach maintenance and approach planning. Most are still, you fill in the blank, reactive or proactive? Reactive. Most are still very reactive, which gives us an opportunity to help them become more proactive. But that's a really nice resource to use. There's also a government policy for water loss control. In the 50s, AWWA coined the term unaccounted for water. And a lot of states adopted that nomenclature of unaccounted for water. AWWA would like people to change that language to non-revenue water. Their point being that water is not unaccounted for. It's just, you're just not getting any money for it, right? So they have really some very nice documentation trying to help municipalities figure out what their non-revenue water is. There's some water audit software that is free to municipalities to use. They have their M55 guide, which specifies F2620 as the fusion method. And I pulled this out of their July report of entities or states which are adopting their kind of non-revenue water thought process. And you'll see the different shadings are whether they have adopted them completely or they've adopted them with independent, like an independent body verifying. So, but if you look at any of the states that have some sort of shading, they have to some degree adopted AWWA's thinking around non-revenue water and how to approach it. And I thought that was kind of interesting and wanted to share that with you. Another great resource is AGA. For those of you working on the natural gas side, the Gas Piping Technology Committee has a guide material for your utilities that has lots of good information in it. It is also ANSI approved. It goes through a balloting stage. Wendy?
Go back to the slide, or do you have it in your resources?
What do you want? This one?
The one before.
This one?
The one before.
One more back?
Yeah. Okay.
Is that the one you want?
I got it.
Okay. No worry. I aim to please. All good.
I'll try to do that.
You're fine. I'll send the whole report to you if you'd like. That's even easier. Okay, GPTC guide, ANSI, also an ANSI approved committee, which means their guidance can be adopted into regulations. They're also doing some really nice work around educating people about the cost of electrification. Electrify Everything, a very interesting read and a very scary, first of all, not even accomplishable, as we heard from Mark yesterday, but policy-driven electrification and what the impacts to that are across the economy. And they've also looked at the cost for a homeowner who is driven to a completely electrical world compared to their balance if they were using natural gas. And their carbon footprint, not just money, but carbon as well. And then they are also watching for local, state, and federal actions around the loss of choice of natural gas. So if you encounter those things in the work that you are doing, AGA, the local AGA could be a resource to you as we think about how we address those. And we're in the process of updating the plastic piping system guide, which is a design document for engineers in natural gas for plastic piping. Another great resource for you, PPI. I don't see anyone in here from PPI today, but I think they had a session at the same time. The handout that is linked in your notebook has some really great technical reports and notes. They have done some nice updates in the last year to both their technical reports and their technical notes. They also have case studies, especially around different installation methods. They have their handbook of PE pipe. It is free. It is, go to the PPI website and download it, and it is free. And it is a great resource. Again, it took a lot of brains and a lot of hours to put it together. Please use it as a reference for you. And they also have a material handling guide, how to handle polyethylene pipe safely. And they have software and videos. So really great resources from PPI that you can apply across your work. And then the Municipal Advisory Board, again, is a group of municipalities who use polyethylene in their systems and have written some guide material. So it isn't McElroy or fill in your favorite pipe company or fill in your favorite contractor's idea. It is municipalities talking to municipalities about what they have benefited out of having a polyethylene system. So a really nice resource to use and deploy and connect your municipalities. And finally, I would be remiss if I did not speak about the PE Alliance, also a really great organization. And I think earlier this weekend, or earlier in Infusion, we talked about the impact that PE Alliance is having in the municipal market, primarily with their engineering package. So Sergio, this could be a place that we can go pull it and use as, hey, here is a really great opportunity for a package ready to go with all the things that you would want a contractor to use when doing a job. They also have a decision tree. You know, one of the questions I think we get asked is, okay, I'm gonna put polyethylene in, but I gotta connect it back to my existing system, or it's gonna break, and how do I fix it? And the PE Alliance has a nice decision tree out there that helps answer that question for people considering polyethylene in their systems. And again, really fantastic podcasts out of the PE Alliance. They do them every week, and they are fantastic. And they have a good library of past podcasts available. Okay, so we talked about the standards. We talked about regulations, kind of what's now and what's coming. We've talked about some industry resources that you might be able to use. You've still got a pretty world-class pit crew here at McElroy. And in addition to the people that are here, whether those are engineering, whether that's IT, whether that is our tech services group or a sales team, in addition to all of our people, we also have some really great tools for you. Starting with our rental and our certified equipment program, right? We have certified rentals, certified equipment. So that is one really nice tool in your toolbox, so to speak. In addition, of course, the data logger. Everything about trackability, traceability, verifying records. The data logger can certainly be an answer to a part of that question. And just because you collect the information, it would be sure nice to know where it is and how to access it and how to use it. And that's our data, that's our vault. And as we learned from Chris yesterday, both from your desktop and from your phone. When we looked at that nice little picture of a flower earlier, qualified operator was one of those requirements, right? And of course, McElroy University is a big piece of how we make sure that people are trained in the field. And then finally, that inspection app that Chris spoke of yesterday, to be able to answer the question when a regulator shows up of how do you know that this equipment is good? There's the inspection app. Tracks that everything is working properly, it was last inspected by, and who could use it. All right, so last bit, there's all sorts of standards out there that can help you and help our customers put good systems in the ground. We've got to do it because there's plenty of regulations out there that affect our work. It's not going to be less in the future. Please, 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 as you're thinking about non-destructive testing, think about this as a quality fusion. How do we create quality in the first place rather than trying to inspect it at the end? And then finally, don't reinvent the wheel. There are lots of industry resources out there for you. McElroy is here for you, our people and our products. We'd really love to support you in the work that you're doing in the field. And thank you, because you're all still awake and it really makes me happy. So thank you. That's my contact information. Feel free to reach out to me anytime. And then I am told that the last slide I have to show you is not the one with the question mark, but is the how was the session. So please do the survey. And we have about 15 minutes, which is what I was supposed to have for you. What questions do you have?
Could you go back one slide?
I will totally go back one slide, or even two, as the case may be.
There we go.
Oh, this is the one you want. There you go. Yes, sir.
What do you see coming for dissimilar wall thickness? What are they gonna, hear different things? Are they gonna allow 1DR? They're gonna go to a non-dissimilar wall thickness? When do you think that's gonna be enforced?
Sure. So Marcus's question is fusion of dissimilar wall thicknesses. So at ASTM, you can already with one DR difference, right? That's written in the current F2620 rule. And there's some guidance that it has been balloted once with regard to how you would approach it differently. And I think that we'll get there where I think it will, I don't know where it will end up, but we will end up with some guidance around it. One DR is, F2620 has been used since the 2000, well, really since the mid-90s as TR33. It was in the original TR33 of 1DR difference. Again, we're not talking about different OD. We're talking about same OD with a different wall thickness is the question we're talking about. So I think there will be some there will be there will be more definition around it within ASTM F2620. I don't think it'll be more than one, but that's just me and my crystal ball.
Has there been any testing when you do 1DR difference that's more than 10% of the whole thing?
Yes, there have been. There's also a whole lot of applications out in the field where it is true. The big question has been if that is happening at a fitting or at a 90 or is that changing? So really the question is it changing the flow? Is there something that's happening in that, in a very discrete location that we're not appreciating or understanding? And that's really the question that's being asked. The data side, I don't know where that data necessarily lives, but we also know that we have lots of systems out in the universe that have differences. The 10% wall thickness piece comes into more play when people are thinking about, as they're aligning the pipe, that they don't have more than that the alignment is close. So I think those two concepts kind of get caught in people's minds of, oh, it's 10% or 1 SDR, which are really different thoughts. And I would say the data says that there's a lot of systems out there with different DRs that are connected to each other that have been good systems. Sure, great question. Yes, sir.
Are we ever going to see a new ASTM standard for electrofusion other than 1290 or a hybrid of NVD 100?
Great question about electrofusion. It's certainly not my expertise. There is, Ed Cooper is working on electrofusion standard right now, and I think it has been balloted for like the 4th time, and I feel like it's very close. So Ed Cooper would be the person I would point you to, and I think his standard is fairly close to being done.
Other question.
Yes, sir.
So in Alberta right now, we are seeing a huge interest in hydrogen only because of they're trying to extend the life of our wonderful oil and gas market. Is it really the big thing that we are definitely seeing, definitely talking on CSA? They're doing a lot of studies, especially hydrogen in gathering lines. So it's definitely looked at a little more seriously.
Right, so I think your question is in Alberta, there's a lot of interest in hydrogen because of the gas fields that are there. And that CSA is doing some work on those standards. So hydrogen, okay, I'll put my engineer hat on. Take my regulatory hat off and put my engineer hat on. So my first answer to you is we already have hydrogen in our natural gas distribution system today. It's there. It hides behind methane on a gas chromatograph. The signal hides behind it. So from a standpoint of, oh my gosh, is it brand new? I would say it's not. In the United States, most places that I'm hearing it, they're talking about up to 10% of the stream. Note to file though, hydrogen does not have a 0 on the global warming potential. It's about 11. So even though it is less than methane, 24, it is still not 0. So hydrogen does reduce a carbon footprint because it is less than methane if you have to use it, but it also has a different BTU content. So there's a lot of pieces at play. From a polyethylene perspective, the hydrogen, we don't have any data that says that hydrogen in a plastic system is a problem. But it still has to have, we still have all the work around seals, gaskets, the steel components, the valves, the mercaptan, how does it deal with mercaptan in a distribution system? Is it going to scavenge it differently than the others? So there's still quite a bit of research to do in that space. But I think that the hydrogen industry, and I'll use that kind of word a little bit loosely, would really like to use the piping systems that already exist. And people who have piping systems and they're thinking, what happens if natural gas is not something that we're going to move around the country in pipes? What can I use my infrastructure with? You know, what Mark talked about yesterday was even if we went to a completely, waved our magic wand and said no more natural gas, we still have 30-year tail of natural gas. And I am certainly, please do not walk out of this room and think that I do not think natural gas is going to be around for 100 years, because I do. That said, there's going to be other things that want to play in our systems, and I think polyethylene pipe is well primed to do that for hydrogen, but there's a lot of other questions that are going to slow that decision down. Does that answer your question? Okay, thank you. Other questions, comments, thoughts, ideas?
Optimized cooling and ISO standards.
Optimized cooling and ISO standards. Ooh, great question. So I'm going to have to ask Jim that answer, because he plays way more in that space than I do. And let me have Jim answer that one, because I know he's walked part of that road. The high force, low force is a part of that answer. So I'll have to table that one, but we'll get an answer to you. Okay, thanks, Darren.
I think what question in my mind, high force, low force, and optimized cooling.
So, great. So Darren is asking, if you're using F2620, then McElroy did thousands and thousands of joints and destructive testing to arrive at our McElroy optimized cooling algorithm. And it works in our high force standards. It works if you're using our data loggers and give it the information it needs. It can calculate a different cooling time for your joint when using F2620. In ISO, those machines are more likely to specify, or those standards are more likely to specify a low fusion pressure. So they had, instead of having 75-pound interfacial pressure, they operated a far lower one with longer time, because it takes longer for that same amount of heat to get into the pipe. So, all that to say that I don't know the answer, but I will have Jim and I will get back with you. Yeah, great question. Unless Jesse knows.
I don't know the answer, but I know just generally speaking, for the low force standard, you have much longer cool times because less of the melt flow is pushed out into the bead. So it would be a whole new set of testing to try to get to something like optimized cooling and low force standard.
Yep. Thank you, Jesse. Other questions, comments, thoughts, ideas, suggestions for this program for next year? Okay. Did this cover what you wanted to cover? And do you have any outstanding questions that you were hoping we would address today?
I think I tried to review one of the package on the specs following that we call the pipe matrix for each of the activities related to the installation of a HDD pipeline will be awesome. In order to check one of those sample of specs related to from ASME with ASTM standard for each one of activities, training, inspection.
Sure.
We kind of see it.
So Sergio's comment was to include something that says, like, here's the standard when you're doing training, here's the standard fusion, here's the standard data logging, like here's the group of standards to put together and when you're going to a package. I think that, sure, that's very doable. Thank you for that suggestion. Okay. Wow. All right, well, I'm going to give you back 10 minutes of your day. I'm not going to make you sit here longer than you need to. Thank you all very much for being here today.